From space, it looks like a scar stretching across the heart of Africa. A deep wound in the earth that runs for more than 6,000 kilometers. The Great Rift Valley. It slices through Ethiopia, Kenya, Tanzania, and beyond, one of the longest and most visible geological features on the planet. To the eye, it's breathtaking. Lakes shimmer in the distance. Volcanoes rise from the plains. Valleys cradle ancient fossils, including some of the earliest evidence of human life. But what most don't realize is that this landscape is alive. It's moving. Beneath its beauty, colossal forces are tearing at the crust. A slow, relentless pull that's literally stretching Africa apart. The same earth that gave birth to humanity may one day split it in two. Scientists call this the East African Rift System, a massive fault zone where the ground itself is cracking, sinking, and reshaping over millions of years. It's a place of both creation and destruction, where continents break, volcanoes rise, and new worlds begin to form. And what's happening here might be one of the most important geological events since the breakup of Pangaea, a process so vast that it could rewrite the map of the world. Because deep beneath these valleys, Africa is beginning to divide. And that's where our story starts. With the forces pulling a continent apart, beneath the grasslands of Kenya and the deserts of Ethiopia, two massive slabs of the Earth's crust are drifting apart. One to the west, the Nubian Plate, which carries most of Africa. The other to the east, the Somali Plate, which holds the Horn of Africa and part of the Indian Ocean coastline. Between them lies the East African Rift, a chain of fractures, valleys, and volcanoes marking the line where the continent is being pulled in opposite directions. It's not dramatic or fast. It's steady, about 7 millimeters a year, roughly the speed your fingernails grow. But over millions of years, even that small motion can tear a continent in half. This movement doesn't stop at Africa's borders. To the north, the Arabian Plate is also drifting away, meeting the African plates in Ethiopia's Afar region, one of the only places on Earth where you can stand on land that's literally splitting open beneath your feet. Scientists call it a triple junction. 3 plates, 3 directions, 1 slow motion separation. So, why is this happening? What's powering this rift, and how can solid rock behave like something alive, stretching, breaking, and reshaping the face of a continent? To understand that, we have to go deeper, down into the hidden machinery that drives our planet itself. To see what's tearing Africa apart, you have to look far below the surface. Down through the crust, deep into the Earth's mantle. Here, the planet isn't solid. It moves. The rock is hot enough to flow, rising and sinking in slow, endless cycles called mantle convection currents, driven by heat from Earth's core. A core as hot as the surface of the sun. As molten rock rises, it pushes against the crust above, stretching it until it begins to crack. Over time, those cracks widen into valleys, and eventually into ocean basins. This slow internal churning once set the ancient supercontinent Gondwana adrift, breaking it into the land masses we know today. Now it's happening again beneath Africa. Many geologists believe a superheated plume beneath East Africa, a column of hot rock pushing upward, is weakening the crust from below. It may be feeding the rift's volcanoes and driving its steady movement. Every tremor, every fissure, every distant eruption, all trace back to that hidden engine beneath our feet. And the deeper it burns, the closer Africa moves toward something extraordinary. The birth of a new ocean. If the rift continues to widen, the results will be unlike anything humanity has ever seen. Over millions of years, the crust beneath East Africa will keep stretching until it becomes too thin to hold itself together. When that happens, the land will sink. And when it sinks low enough, water will find a way in. That's how oceans are born. The Indian Ocean, just a few hundred kilometers away, will eventually breach the valley and flood into the depression, creating an entirely new ocean basin. A body of water that could one day separate Eastern Africa from the rest of the continent. Scientists estimate that when this happens, a new landmass will emerge, a smaller continent made up of Ethiopia, Somalia, Kenya, and Tanzania, drifting slowly eastward into the Indian Ocean. What we know as inland valleys and lakes today would become coastlines. Mountains would rise as the rift shoulders expand, and volcanoes would mark the newborn edges of a future sea. It's not just a theoretical event. The same process once created the Red Sea, when the Arabian Plate tore away from Africa around 30 million years ago. Now that same pattern is repeating, quietly, steadily, beneath our feet. But where there's heat and pressure, there's also power. Lengai and East Africa is sitting on an energy source most countries can only dream of. The same volcanic heat that splits continents can also light cities. Across Kenya and Ethiopia, that power is already being tapped. Here, the Earth's crust is thin. Only a few kilometers separate the surface from vast chambers of steam and molten rock. By drilling into these geothermal reservoirs, engineers can harness the planet's natural heat to generate electricity. Today, Kenya ranks among the world's top producers of geothermal energy, generating over 1,000 megawatts. Ethiopia is close behind, expanding its capacity every year. For a region that has long battled energy shortages, the rift's fiery heart is becoming its greatest resource. It's clean, it's renewable, and it's local, drawn directly from the same forces reshaping the land. But it's also a reminder that the ground beneath is far from stable. Every new borehole, every puff of steam, is a glimpse of the restless power moving just below the surface. That same heat that powers homes today could one day tear them from the ground. Before we go deeper, if you enjoy exploring how the planet reshapes itself, take a moment to subscribe. It helps us keep uncovering these hidden worlds beneath our feet. Now let's look at the evidence that Africa really is splitting apart. The first warning signs. Cracks opening overnight, splitting roads and fields in two. The signs aren't just buried underground. They're written across the land itself. In 2005, a massive crack appeared in Ethiopia's Afar region. It stretched for nearly 60 kilometers and was 8 meters wide, opening in a matter of days. At first, locals thought it was caused by an earthquake, but scientists soon traced it to something deeper, an eruption at the nearby Dabahu volcano. When the volcano released a surge of magma, it forced its way through the crust, splitting open the ground above. In that brief moment, Africa's slow separation became visible to the naked eye. Then in 2018, another fissure made headlines in southern Kenya. A 1-kilometer-long chasm tore through a highway, swallowing parts of the road and nearby farmland. It looked like the continent had cracked again. But this time, the cause was less dramatic. Heavy rainfall had eroded ancient layers of volcanic ash, exposing a pre-existing fault that had lain hidden for centuries. Still, both events showed one thing clearly. This land is fragile, constantly adjusting and under strain. Satellites now record small but consistent movements, a few millimeters every year, the Earth stretching as if taking a slow, deliberate breath. And that raises the question scientists are still debating. What happens if this rift doesn't complete its split? If the process stalls halfway? Not every rift succeeds in splitting a continent, but some begin with enormous power, then fade into silence, frozen mid-separation. 1 billion years ago, something similar happened in North America. It's called the Mid-Continent Rift System, a scar that stretches over 3,000 kilometers through what's now the Great Lakes region. It began to tear the continent apart, just like the East African Rift today. But before it could finish, it stopped. Instead of forming an ocean, magma surged upward and flooded the rift with basalt lava. Billions of tons of molten rock that hardened into stone, sealing the gap and holding the continent together. That's what scientists call a failed rift. A split that started but never completed. Could Africa's rift meet the same fate? If the magma beneath East Africa cools or loses energy, the rift might stall. It would remain as a long chain of valleys and volcanoes. A visible scar, but not a new ocean. But if that pressure doesn't fade, if it keeps building beneath the crust, it won't just stall, it will burst. And when continents fail to separate, they sometimes erupt instead. If the rift can't spread sideways, all that pressure has only one direction left to go. Up. When magma trapped underground has nowhere to move, it forces its way through cracks in the crust, flooding the surface in vast sheets of lava. These events are called large igneous provinces, or LIPS. Colossal outpourings of molten rock that can reshape continents and alter the planet's climate. It's happened before. The Laki eruption in Iceland in 1783 released 14 cubic kilometers of lava. Enough to fill the sky with haze, kill crops across Europe, and cause years of famine. Now imagine that on a scale hundreds of times larger. If the East African Rift behaved the same way, half of Ethiopia, Kenya, and Tanzania could be buried under rivers of lava stretching for hundreds of kilometers. It would scorch farmland, poison the air, and release massive amounts of gas into the atmosphere. Temperatures could plunge, harvests would fail, and volcanic winters could ripple across continents. That's the catastrophic scenario geologists hope will never happen. But with dozens of active volcanoes along the rift, the risk isn't theoretical, because the rift is already venting its heat. Through fire, stretching from Ethiopia down to Mozambique, the East African Rift is lined with volcanoes, more than 70 in total. Some are quiet, others restless, and a few are among the most dangerous on Earth. In the Democratic Republic of Congo, Mount Nyiragongo is one of them. It holds the world's fastest moving lava, so fluid it can flow downhill at more than 60 kilometers an hour. In 1977, it burst without warning, emptying its lava lake and killing hundreds within minutes. It erupted again in 2002, destroying parts of the city of Goma, and once more in 2021. Farther south, Tanzania's Old Doinyo Lengai produces something even stranger, carbonatite lava. It's cooler, darker, and runs almost like liquid oil. Because it's less viscous, it can travel much farther and faster than normal lava, blanketing vast areas before it cools. It's the only active volcano of its kind on Earth. In Ethiopia, Dabahu and nearby volcanoes in the Afar Triangle show constant swelling and small eruptions. Signs of magma rising below. Satellite monitoring has detected land deformation across the region, confirming the crust is stretching and shifting. These volcanoes are not isolated events. They're part of one connected system, a line of weakness running down the heart of Africa. And what happens here doesn't stay local. When a rift evolves, it affects the entire planet. The East African Rift isn't just rewriting local geography. It's shaping the planet's future. If the continent continues to pull apart, new coastlines will form, and existing ecosystems will change forever. Valleys will sink into deep basins, filling with water to form new lakes and inland seas. Regions that are now arid could become humid, while fertile farmlands might drown beneath rising waters. The geological shift would also reshape biodiversity. Species separated by the growing rift would evolve apart, creating new ecosystems, just as Africa's Great Lakes once did millions of years ago. But the transition would be costly. Tectonic instability could destroy infrastructure, displace millions, and threaten agriculture across East Africa. Globally, large eruptions tied to this rift could alter climate on a massive scale. A single event releasing enough sulfur dioxide could dim sunlight for years, dropping temperatures worldwide. Famine and food shortages could spread far beyond Africa's borders. Even without catastrophe, the geopolitical map would change. New maritime routes could emerge as a future ocean opens, forcing nations to redefine their borders and economic zones. The rift's evolution isn't just a regional event, it's a slow-motion transformation that could influence global weather, trade, and life itself. But all of it depends on one thing: time, and how long this process will take. The question everyone asks is when. When will Africa actually split? When will a new ocean appear? The honest answer: not anytime soon. The plates beneath East Africa are moving apart at only 6 to 7 millimeters per year, slower than your hair grows. At that pace, it will take tens of millions of years before the Indian Ocean floods the valley to form a true ocean basin. But every earthquake, eruption, and sinking valley is part of a much larger process already underway. We are witnessing the earliest stage of continental breakup, the kind that has shaped every landmass on Earth. Scientists are tracking it closely. GPS stations measure subtle ground shifts, satellites capture surface deformation, and seismographs record tremors no human can feel. Each data point adds another frame to the planet's longest-running story: how Earth rebuilds itself from within. And one day, far beyond our lifetimes, the map of Africa will look entirely different. A new ocean will stretch where the Rift Valley once lay. Mountains will guard new shores, and what began as a crack will have become the cradle of a new world. Because Earth is never still. It's alive, and Africa's next chapter has already begun. If this journey through the Great Rift fascinated you, don't forget to like, share, and subscribe. We explore how Earth keeps changing, one story at a time.